Okay, so this is the review for the Chapter 5 test. So bear in mind, some of the questions on the test are going to be in a non-graphing calculator or any calculator portion of the test. So some of the questions that we're going to do here, you will not have access to your graphing calculator. So I'm going to show you how we're doing these problems without that graphing calculator. Okay? So in the first problem, so in this whole box, we are simplifying, and when we get towards the bottom, we'll be solving. And you will be expected to show your work. So the idea is, what is 27 to the negative 1/3 power? So I don't know what 27 to the negative 1/3 power is. What I do know is that a negative exponent moves it down first, and that a 1/3 power is the same as a cube root. And then as part of our extra credit quiz, you were expected to know that the cubed root of 27 is 3. So when you're done, this is 1/3. Okay? The next problem, how do you simplify this? The rule is that there is no radical in the denominator. So when you have a problem like this, you're going to multiply it. We called it by the conjugate. And that means I'm going to multiply it by 1 plus the square root of 5. And I'll do the same to the top, because that just means I'm taking this fraction and multiplying it by 1. So for the top, I'm going to distribute the 2. And 2 to 1 is 2, and 2 times the square root of 5. They aren't similar enough to multiply them, so I'm just going to write it as 2 times the square root of 5. And then in the bottom, we talked about that this thing, the conjugate, works because if you have FOIL, first, outside, inside, last, that you actually just need to do the F and the L. We called it full. So I'm just going to multiply 1 and 1 for 1, and then the negative square root with that. So the minus is going to come along, and the square root of 5 and the square root of 5 multiplied is the square root of 25, which just changes to a 5. So when I'm done, my numerator will stay the same, but then I can take 1 minus 5 and get negative 4. And this is a great answer. If you notice that simplifying triangle that we talked about, that you can take a 2 out of those, that would be great. I can divide this by 2, I can divide this by 2, and I can divide this by 2. So this is the better answer, okay? But this one will be accepted on the test. All right, the next problem, we're simplifying, and one of the rules is you can't have anything perfect under there. So I've went ahead and made the factor tree for 32. And this is where we talked about you can make the perfect, there's a little 2 here, and the not perfect. So here's my perfect, here's my not perfect. So of these 5 2's, 4 of them are perfect and 1's not. I don't have enough x's to be perfect. Of the 9 y's, 8 are perfect and 1 is not, and all my z's are perfect. And what makes them perfect is that 2 goes into their exponent perfectly. There's no remainder. So the 2 and the y and the z will come out, and I just use division to get their exponents. 2 goes into 4 2 times, 2 goes into these 8's 4 times, and then it would be better to turn the 2 squared into a 4. And then here's the rest. And then all of this stuff will just stay in there. So when I'm done, here is my answer. Okay? So 64, again, the idea of 64 is it's not number 64. This problem is I don't know what 64 to the 5/3 power is, so I'm going to rewrite it. And when you rewrite it, the denominator becomes the index number. So the cubed root of 64 is 4. And then you might need a calculator for this, but otherwise you're taking 4 to the 5th power. And this should be a problem on the test that you don't need a calculator, but 4 to the 5th power is 1024. Okay? But on the test, I'm looking for this work to be shown in this work. I don't want just 1/3 or even the decimal, and I don't want this. I want the work that gets you there. All right, adding, subtracting, very picky rules. You need to find something common to add or subtract, and right now these don't. So the idea is I'm going to try to simplify these radicals so that I can subtract them when I'm done. So the 5 and radical 3, I'm going to leave alone because 3 is prime. You can't factor that down anymore. But 12, and because this is a square root, I'm just going to break it into the square root of 4 and the square root of 3. I don't think I need to make the factor tree for this one. Square roots are a little bit easier to work with than some of the other roots. So the square root of 4 can become a 2. And now I'm ready to subtract because there's something common between the two that I can subtract. So when I'm done, I have 3 of these square roots of 3. And the same thing's going to happen here. I'm going to try to simplify the radicals so that I can make them so that they are subtractable. So 5 you can't simplify anymore. It's prime, so it's going to stay the way it is. And because this is a square root, and it will just be a square root on the test, I'm going to break it down into the square root of 9 and the square root of 5. So this one stays the way it is. And now this becomes a 3 with the square root of 5. So when I'm done, I have 2 of these square roots of 5. Oops, you can't see that. All right, moving on. So this problem, first, I'm going to get this problem to look the way it did in more of our other ones where we broke it up into 2 square roots. But as it turns out, these are both perfect, and I don't need to do any of this stuff that we'll do over here. I can just take the square root of this, it's x. I can take the square root of 25, it's 5, and you're done. All right, and a problem like this, so this problem, I think you're going to see it on the back, is where it becomes such a big problem, we organized it, and the first step is if there were parentheses, which there aren't, I would distribute the parentheses exponent into all the other exponents. Then the second step is I would organize it, I would make houses. So I've got a fraction, so I'm going to make a fraction bar, and I'm just going to go through and put my numbers in a house, so 12 and 2, and I'm going to cross them off. I'm going to put my x's in the house, so they all go where they normally are because there are no exponents or negative exponents. And then I'm going to put the y's in a house. And I've gotten everything. So the idea is instead of one big problem, I have 3 little problems. And 12 divided by 2, don't subtract these, is 6. When I combine these, I have 6 x's. If you notice over here, these y's will just cancel out so that when you're done, hold on, you're going to have a y squared in the bottom. And that's your answer for this problem. All right, so this one, what I'm going to do is make this problem look more like this problem. So the first thing is just multiply them. I'm not going to multiply 27 and 9 because I'm just going to have to break them into factor trees anyway. So, but I can combine the x's into x to the 5th. So what I'm going to do instead is, and again, you can multiply 27 and 9 and then make a factor tree of that, but I'm going to make a factor tree of 27. And a factor tree of 27, as it turns out, turns into 3 3s. And a factor tree of 9 turns into 2 3s. So when I'm done, I can rewrite this as a total of 5 3s and 5 x's. And as it turns out, they're both perfect. And they can both come out, and their exponent, 5 goes into 5. It would just be a 1, which you don't need the 1, but you can put the 1 if you want. All right, this one, that's not numbered. I don't want to say number 3. So first I'm going to make a factor tree for 8. As it turns out, that becomes 2 cubed. Here's the rest. And then I would have the perfect and the not perfect. Sometimes when we do this, we leave out the cubed. Try to bring it through so you remember which one you're working with. So all my 2's are perfect. All my x's are perfect. All my y's are perfect because 3 goes into their exponent perfectly. Now of my z's, 3 are perfect, but 1's not. So this 1 z will stay in, and then the 2, the x, and the y, and the z will all come out, and they'll all have an exponent of 1. 3 goes into 3 one time, except for the 6. 3 goes into 6 2 times. All right, this problem is just like the problem at the top. You can't have that radical in the bottom, but to get rid of this radical, and how we multiplied by the conjugate, I'm going to multiply it by the conjugate. And it just means you're going to multiply it with the same 2 terms, but an addition sign instead. So again, I'll start with the 2. The 2 will distribute to the top. I'll get 6, and I'll get 2 square root of 5. In the bottom, you can multiply this, the 3 visits the neighbors, the radical 5 visits the neighbors, but the conjugate's going to make things cancel out. So again, you can just do f first, so that's 9, and I'm going to have a minus sign because when I multiply the L of full, so square root of 25, that'll just turn into 5. So when I'm done, I'm going to have 6 plus 2 square root of 5 over 4. This is a great answer if you left it like this, but if you see this triangle that you can take a 2 out of, and divide that by 2, you get 3, divide that by 2, you just have the square root of 5, and divide that by 2, and you have 2. So this is the better answer, but that one will be accepted. All right, in this problem, the first step I'm going to do, and I wrote this on a lot of your content checks, or if you talked to me about it, I wrote it down on your content check, is I'm just going to try to simplify. So right now, 18 and 49, I can't simplify, but I am going to separate them out into 2 radicals. The next thing I'm going to do is simplify the x's, so I'm going to have 4 x's on top, and I'll end up having 4 z's on top and 3 z's in the bottom. After I do that, I'm going to make a factor tree of 18 and 49. So 18, when I'm done with factor tree, becomes 2 and 3 squared, along with the stuff that's already there. And 49, when it's a factor tree, becomes 7 squared. So now that I've done that, what I want to do is make the denominator perfect. So I'm going to multiply it with another square root, and there are little 2's here, and I need to fix the denominator so it's perfect. So right now my 7's are perfect, no problem. But I need more z's. I need 1 more z, and that means I'll have to put 1 more z in the top. And then what I would have written on your content check is multiply your numerator and the denominator. So for the denominator, when I multiply it, I'll have 2 7's and 4 z's, and I'm going to put that little 2 that's there. And in the top, I'm just going to bring everything along. So I'll have 2, but I'll put a first power with it. I'll have 3 squared, x to the 4th, and y to the 4th. And now what I want to do is take everything out that's perfect. So this 2 is not perfect. It's going to stay in there. I'm trying to think where I can put my answer. I don't have a lot of room here. There we go. I'm going to put a little sticky note here. So this 2 will stay in there. Okay, let me put it below. The 3 can come out, so here's my fraction bar. The x to the 4th can come out as x squared, and the y to the 4th can come out as y squared. And in the bottom, both of those can come out, 7 and then z squared. And then that's my answer. I can't do any more simplifying out here. So, okay, that is the answer for the bottom right one. All right, moving on to the next page. So what I did is I went ahead and made a factor tree of 64. It turns out it's 2 to the 6th. I'm going to break it up into the perfect, into the not perfect, and all my 2's are perfect. Of my 4 x's, 3 are perfect, 1 is not, and none of my y's are perfect. I don't have enough. So I'll take out the perfect stuff, 2 and x, and their exponents will 2 goes into 6 twice, 3 goes into 3 once. I won't put the 1. And 2 squared is fine, but I would prefer that you actually change it into 4x, and then this stuff will stay inside. All right, a problem like this. So this kind of combines what we were doing on the front a little bit. I have an exponent with parentheses, and I'm just going to distribute this in there first. My steps say deal with your parentheses. So when I take 2 times negative 1/3, I get x to the negative 2/3. And then there's really nothing to organize because there's only one thing, but the negative exponent says just move that to the top. So this is what I'm looking for on an answer here. All right, next problem. Parentheses, lots of multiplying in here with exponents. So this 1/2 is going to go to every power, to the 16, to the 10, and even to the 25's power, which is 1. So I'm going to have 25 to the 1/2 power. And 25 to the 1/2 power, that's like the square root of 25, which is 5. I'm going to have a half of 10, so a is going to have a power of 5 because I'm multiplying, and half of 16 is 8. All right, so now we're going to get into the solving, and just to point out on the directions, when solving, check for extraneous solutions. When we get to the bottom part, this is where I'm going to ask that you check both ways, graphing and algebraically. So these are more solving. When we do these problems, and there's just a blank here on purpose, I'm just going to check algebraically, okay? Okay, so starting the solving, my job is to isolate the radical, isolate the exponent. In this problem, though, it's just like the square root method. We're just going to get x by itself. So I need to start moving the 2, the 1, and the 3, and you're just going to work backwards in the order of operations, okay? So there's no addition subtraction to move except for the stuff in the parentheses. So I'll get that at the end. So I don't have to do this step. But now I'm going to move the 2. Don't move it in, move it away. So I'm going to divide by 2. I'm going to get x minus 1 to the third power, and over here I'm going to get 8. And now, to get rid of the exponent, since they cubed it, I'm going to cube root. And I'm going to get x minus 1. And the cubed root of 8 is 2. It's not negative 2, it's just 2. When you take an odd root, it's just whatever the calculator says. And now to get x by itself, I'm just going to add 1 over, and I get 3. So how do I know if this really works? Just put 3 back in there. So if I put 3 into my problem, do I really get 16? So order of operations would tell me to do parentheses first, that's 2. And then I would do the exponent next. 2 cubed is 8. And then 8 times 2 is 16. And again, you can just type this into your calculator and you'll see that 16 is your answer, so this works. So no extraneous solutions here, this works. All right, next one, solve for x. Same type of problem, just slightly different numbers. Working backwards in the order of operations. There's the addition, subtraction in the parentheses, so we'll get rid of that last. I'm going to move the 2 away, not distribute it in. I'm going to divide by 2. So that gives me 16. Now to get rid of the fourth power, I'm going to fourth root. And just a reminder, fourth root on your calculator is where you have to type the 4 in first, then press the math button and choose the 5th option. And some of yours will look like this. Some will have a regular size 4 and there will be an X where that little 4 is, but it means the same thing. So my calculator is going to tell me 2, but what I'm going to have to remember, since I'm taking the even root, that it's not just 2, but it's also negative 2. So I'm going to have x minus 1 equaling 2 and x minus 1 equaling negative 2. So when I add 1 here, I get 3, and when I add 1 here, I get negative 1. Whoops. And then do these really work? Well, just put 3 in here. So I'm going to go into this box. And do I get 32? Order of operations, I get 2, and then 2 to the 4th power is 16, and 2 times 16 is 32. So yes, 3 works. And then negative 1. So negative 1 minus negative 1 is negative 2. And negative 2, make sure you type it in correctly, to the 4th power is 16. And when I'm done, yes, 32 equals 32. Okay? All right, next problem. So now we're getting into the radical problems, and this is where you just need to isolate the radical. So I need to make sure that this is by itself. So you essentially work backwards in the order of operations. First I'm going to add 5 over. And now to get rid of a 1/3, I'm going to multiply by the reciprocal, because that's going to become 3 over 3, which is 1, and that's how I'm just left with the cubed root of x minus 8. And then I'm going to multiply this side by 3, so I get 15. And now that I've isolated the radical, I'm going to get rid of the radical. So if they cube root it, I'm going to cube it. And those 3 basically cancel each other out, so I'm left with x minus 8. Then I'll cube 15, and I'll use my calculator for that. And I get this number. And now to get x by itself, I'm just going to add 8 over, and my answer is 3,383. So now I just want to see, does that really work? And again, I think it's faster to check it algebraically. So I'm just going to use my calculator, and I'm going to put that number in. I have a lot of room here. Okay, sorry, that's squished. So how do you type that in your calculator? First, I'll type in a third. I'll put it in parentheses. And then I'll get my cube root, so that's just math, and you choose the 4th option. And then some of you might have to start the parentheses depending on the operating system. I'll go ahead and do it. And I'm going to put 3383 minus 8. And then close the parentheses or use the right arrow and get out of the radical. And then minus 5. And do I get 0? I do. So when I'm done, I get 0. So this works. No extraneous solutions. All right, next one. First up is isolate the radical. It already is isolated. Next, get rid of the radical. So to undo a square root, I'm going to square this side, and I'm going to square this side. So this square gets rid of that square root, so you're just left with 2x plus 6. You do not get to distribute the squared because that plus is stopping you. Anything with addition or subtraction has picky rules, so it really means to multiply. And as you guys are starting to say as well, I have neighbors visiting neighbors. So I'm going to get x squared and 3x, and then 3 is going to visit, and I get 3x and 9, and when I'm done I have x squared plus 6x plus 9 on this side. And there's the other side. So now we're back to first semester. How do I solve this? Well, I have more than one type of x, so I'm going to get everything on one side, and I'm going to factor it. So I'm going to subtract the 2x over to the 6x, and that gives me 4x. And I'm going to subtract the 6 over to the 9, and that gives me 3. And then you can factor it. So factors of 3x squared, that give you 4x. Well, that's going to be 1x and 3x. And then you can rewrite it, or you can box it. If you box it, here's your box. Okay, so I'll continue with this way. I'm going to group them. And the first set, I can factor out an x and get an x plus 1 left, which is what I'll need here. I'm just going to write it below. And so I'm going to take a 3 out to get that x plus 1, and when I'm done, my parentheses are x plus 3 and x plus 1. But you're not done yet. You still need to ask yourself what makes those 0. So negative 3 and negative 1. So those are my solutions so far. So do they work? Well, to find out if they work, you're just going to plug them back in. So I'm running out of room. So I'm going to just grab another piece of paper. And first I'm going to put negative 3 in there, and does it work? So first I'm going to start with negative 3 in here. So on the right side I get 0. On this side I get negative 6, and negative 6 plus 6 is 0. And the square root of 0 is 0. So negative 3 works. That's the solution. So now I'm going to see if negative 1 works. So putting negative 1 in, wherever there's an x. So here I get negative 2, and negative 2 plus 6 is 4, and the square root of 4 is 2. And if I add this side up, I also get 2. So they both work. There are no extraneous solutions, so both count. And the last problem. I need to isolate the radical. This is like a radical. So they're just writing it as a rational exponent. So to isolate it, I'm going to divide by 3. And that's going to give me 16 over here. And now to get rid of the exponent, I'm going to use the exponent's reciprocal. And I'm going to take this to a 3/4 power, because this gives me an exponent of 12 over 12, which is 1. And then I don't need to write a first power. And then I'm going to do that over here. So you can type this into your calculator, but what you need to realize is that in the end you will be taking the 4 through to 16. And when you take an even root, you get 2 answers. So the 4 through to 16 is 2, but it's also negative 2. And then when I take that and I cube it, that's the next step, I'm going to get an 8 and a negative 8 out of that. So if you type it into your calculator, it will just give you 8. You're going to have to realize, did I take an even root? You did, so you should make it negative 8 as well. All right, so now I'm going to have 2 problems, x plus 1 with 8, x plus 1 with negative 8, and now I'm just going to subtract, and I'm going to get 7, and over here I'm going to get negative 9. And now I just want to see, do these really work? So I'm going to go back and check in the original problem. So first I'm going to try 7. So putting 7 in. And you can type this in. In the end, you'll be taking 8 to the 4/3 power, which just means you'll be taking the cubed root of 8, which is 2, and then taking that 2 to the 4th power, and getting, oh, I can't even think anymore, 16, I believe, right? 16. and then bringing this 3 down, multiplying it to the 3 and getting 48. But again, you can just type this in exactly as you see it, and you'll see that you get 48 equals 48. So 7 is the solution that works. Good. Now we're going to try negative 9. So if I put negative 9 in there, and this one I'll just do on the calculator. Do we get 48? So I'll do 3 in parentheses, negative 9 plus 1, exponent. Some of you need to put the exponent in parentheses. And I'm just going to hit enter. And I get 48. So yes, we get 48 equals 48. No extraneous solutions here. These both work. Okay? All right, now we're going to get into the ones that will have extraneous solutions. And you will have one question on the test that wants you to show this both ways. So this column is just where I'm going to solve. So for a 1/2 is just like a square root, so I'm supposed to isolate it, and it already is. Now I'm going to get rid of the exponent, and to get rid of a 1/2 power, I'm just going to square it. So on this side I get 9x minus 20, because it's to a first power now, and a first power you don't write. And now when I look at the problem, I have more than one type of x, so I'm going to bring everything over to one side so I can factor. You can also do the quadratic formula if you want. So factors of 20, x squared, that get you to negative 9x, and that will be a negative 5x and a negative 4x. And then you can rewrite it. Some of you know that there is a faster way to factor this. Or you could put this in a box, but I still have x squared, negative 9x, and 20. And then I'm going to group them. And now I'll go for my first set of parentheses. I can factor out an 8. And x times what gives me x squared is x, and x times what gives me the 5 is 5. And then I'll have my matching parentheses. And what times x gives me negative 4? It's a negative 4. And my parentheses are x minus 4, x minus 5. So my solutions at this point are 4 and 5. So now we're going to check algebraically, and we're going to check graphically. So algebraically, I'm going to make a column. And first I'm going to check x is 4. And I'm just going to let my calculator do the work. So I'll be typing this in just a moment. So I just put an x, the 4, wherever there was an x. So in parentheses, 9 times 4 minus 20. Take that all to a 1/2 power. I'm just going to do 0.5. And I get 4. So yes, 4 does equal 4. 4 works. And now I'm going to check 5. So I'm going to put 5 in this time. Alright, so in parentheses, 9 times 5 minus 20, take it to a 1/2 power, and it works. So 5 equals 5. So how do you do this on your graphing calculator? Well, the way you do this is you're going to go over to your equation and maybe draw a line. And on the left side, if you made x become negative 4 and you do your math, the right side will represent your y. You're supposed to get 4. So I need to make sure I can see the point 44. And on the left, if x is 5, and I do the math, then on the right side, that'll represent my y coordinate. It should be 5. So I need to make sure that in my window, I can see 5, 5. Okay, to see graphically, I've gone ahead and I've put in the left side into y1 and the right side into y2, the original problem with the x's. And I need to make sure I can see the point 44 and 5, 5. So how did I come up with that? Well, I just draw a line in between my equal signs, and I'm going to let the left side determine the x value and the right side determine the y value. So if x is 4, so I choose 4, and I do the math, then over here I should get 4 as my answer. And on this side, if I put 5 in and I do the math, I should get 5 as my answer. So I need to make sure I can see 4, 4, and 5, 5. So for my min, I'm going to start it at 0 and go up to 10. And my y min, I'm going to start it at 0 and go up to 10. All right, hitting graph right now. All right, so it's kind of hard to see, but it is actually meeting it twice here. Here's 1, 2, 3, 4. It's meeting it right about there and then right about there. So just trust, I guess, that you did this right, and I'm going to verify it now by doing second trace, going to the calc, choosing my intersect, and I'm just going to move this arrow more to the left side first and just hit enter 3 times. So I can see that 4, 4 works, and then I'm going to verify it again and choose option 5, and this time move it over more to the right because I know it's supposed to hit it twice. And in my window, you know, if this is from 0 to 10, I know that 5 is here. So just hit enter 3 times, and there's the other one. So what will I draw for a picture? Well, first I'm going to put in my min, or my window range, so 0 to 10, 0 to 10. And then I'm just going to draw a straight line going across, and then I kind of had a curved line going through that actually did something like this. So here's 4, 4, and here's 5, 5. And on the test, it won't be this difficult to see. They won't be that close. You will have a very easy picture to see. All right, trying the next one. So first I'm going to solve it. So first I need to isolate the radical, which I've done. Now I'm going to get rid of the radical by squaring both sides. And now to solve for x, I can just get x by itself, so I'm going to get x is 15. So first let's make sure it works algebraically. So I'm going to put 15 in. And this one I will not use my calculator because this is pretty simple. So I'll get the square root of 16. The square root of 16 is 4. So that should work. So how do I see on my picture? First, go to y equals. Put the left side into y1. So I'm going to have the square root of x plus 1. Then I'm going to go to y2 and put in 4. And then again, I need to see if x is 15, sorry. So if I do x is 15 over here and I do the math, my y should be 4. So I need to be able to see the point 15, 4. So with the window that I'm in right now, I won't see 15. So I'm going to actually up it up to 20. And then in my y, I should see 4. So I want to adjust that. All right, so here's the first one. And there we go. So I can see it. So first I'll just draw the picture. Kind of just something like this. And then I have a line going across. And I will be verifying this point in a second. The window that we had set up, or I set up, was from 0 to 20 and 0 to 10. And now just verifying that that point is 15, 4, I'm going to do second trace. I'm going to choose the 5th option. And just hit enter 3 times because there's only one, the calculator. You don't have to direct it. And that it's there. It's 15, 4. So I've verified both algebraically and graphically that there is no extraneous solution, that the solution works. All right, graphing. You will definitely not have your graphing calculator for this portion of the test. So you'll have to make your table, describe the transformation. You're going to graph both the transformed and the parent, and then the domain of just the transformed. So square roots. On the content check, some people were switching these around. In square roots, we chose the numbers 0, 1, 4, and 9 because I can take the square root of them very easily. So the square root of those numbers are 0, 1, 2, and 3. Okay, so here they are graphed. And I'm not going to connect them. I'm just going to leave them be. Okay? But now I'm going to start dealing with the transformation. So what is the transformation? Well, it's going to stretch by 2. It's going to go right 1 and up 3. So stretch by 2, right 1, up 3. So first I'm going to deal with the stretch, and I'm just going to take all of these y's here and double them, not the x's, the y's. So 0 stays 0, this becomes 2, this becomes 4, this becomes 6, and I no longer need these points. So right now 0, 0 doesn't get to stretch, but 1, 1 has stretched to 1, 2, 4, 2 has stretched to 4, 4, and 9, 3 has stretched to 9, 6. But they're not going to stay there. They're still each going to go right 1 and up 3. So don't forget 0, 0. It's going to go right 1 and up 3. And now this point is going to go right 1 up 3, right 1, up 3, right 1, up 3. And now instead of starting here, it's going to start here. And it's starting at 1, 3. And then it's still going to infinity, infinity. So now when I do the domain, the lowest x is 1, right there, and the highest x is infinity. And the range, the lowest range is now starting at 3, the y, and going up to infinity. The next one is a cube root. So again, with your t-chart, you need to remember that the points we picked for our t-chart were -8, -1, 0, 1, and 8, because we can take all of those cube roots really easily. And so I'm going to graph those really fast. I always do the 8s and 2s first. And then the 1s and 0s make a little diagonal, and I'm not going to connect them, but it's like a very flat S. And so now what I'm going to do is describe the transformation. So it's going to flip. It's going to go left 3 and down 1. So first I deal with the flip, and the flip just says take all of these y's and make them the opposite. So it becomes 2, 1, 0, -1, and -2. So right now, this has flipped to here. This has flipped to here. 0, 0 doesn't flip. It's on the x-axis. This flips down here, and this flips down here. And these are temporary points, because now they're still all going to go left 3 and down 1. So left 3, down 1. This one goes left 3, down 1. Right, 1, 2, 3. This one is going to go left 3. So 0, 0 never flipped. Left 3, down 1. This one flipped to here, and it's going to go left 3, down 1. And this one will go left 3, down 1. And now these are the new points I connect. And you have to do all these pieces on the test to get all the points. So the domain doesn't change. This is still x is going to the left, -infinity. X is going to the right, infinity. Over here, though, the range is going to change. It's going up, so infinity, and on the right it's going down, so -infinity. But regardless, it's still infinity. So the lowest x is -infinity to infinity, and then the same for the range. The lowest will still be negative to infinity. All right, long review, lots of practice. Okay, now we're into the more recent stuff. So we have these two functions, and our job is to either add or subtract them, maybe multiply or divide them, and then evaluate them. So this just says take your two functions, f of x and subtract g of x, and you are able to subtract these because they're both square roots. But first I'm just going to add the opposite. So when I'm done, I'll add the 2 and 4 and get 6 square root of x. And then I'll do the same, but this time I'm going to add them. So 2 square root of x plus -4 square root of x. So when I'm done, I can add these, the 2 and the -4, and get -2 square root of x. Now this just says evaluate in your new version of it. So here's the new version of it after I added them. Just put 16 into here. You can put 16 in here and then add them up, but this will be faster. The square root of 16 is 4. So when I'm done, -8 is my answer. And the same thing. I'm just going to put 16 into here. 6 times 4 is 24. Okay? Another problem, but this time we're going to be multiplying and dividing. So I'm going to take f of x times g of x. And now this is problems like the front. I'm going to make houses. I'm going to put half and 8 in a house. And then I'm going to put my x's in a house. And I have two little problems. So I'm going to multiply half of 8. That's 4. And then this, I'm supposed to add the exponents. So if I think of measuring cups, a half a cup and a fourth a cup is 3/4 of a cup, but you could always add a half and a fourth on your calculator and get your answer. And now I'm going to do the same thing, but I'm going to divide them. So here's f of x, and here's g of x. And so I'm going to take a half and divide it by 8. Basically what happens when you make your house, the half moves down here with the 8. But you could also just go to your calculator if it helps, and I would do 0.5 divided by 8. You get that, turn it back into a fraction, and you're going to get the 1/16, which is what we'll get here in a moment. And then my x's. So again, measuring cups, I have a half a cup, and I take away a fourth a cup. That's a fourth a cup. And since there are more x's on top, that's where that 1/4 will end up. But you could always subtract a half and a fourth on your calculator. So anyway, I don't need the 1. You could put the 1, but I'll just put the 16 in the bottom. Now what I'm supposed to do is evaluate this new function. Put 16 into here. If you want to use your calculator, you're more than welcome to. But again, just a reminder that that's the same as the 4th root of 16, which you'll eventually take to the 3rd power. So that's 2. And then 2 to the 3rd power is 8, which you'll take times the 4 and get 32. If you just type this all in, just make sure, some of you need to wrap that in parentheses. And then this says just take your division problem and do the same thing. So I'm going to put 16 in. And you got 2 ways you could do this. What I'm going to do is just take the 4th root of 16, which is 2, and then take 2/16 and get 1/8. If the other way you could look at this is you could subtract the exponents because they're the same base, and a fourth take away 1 is negative 3/4 or 3/4, and it says that that 3/4 should be on the bottom. And then again, look at this as the 4th root is 16, which is 2, and then take that 2 to the 3rd power and get the 8 that's in the bottom. All right, believe it or not, almost done. Okay, newest part, finding the inverse. So the inverse means there's 2 types of inverses. One is to switch x and y around and solve for y, which is what the bulk of this is. So h of x I'm just going to return into y, and this is the x. And I'm going to switch x and y around, switch their spots. And my job now is just to solve for y, get y by itself. So you are working backwards in the order of operations. So the first thing I'm going to do is add 4. So on this side, I'm just going to have x plus 4 now. You can't make it 4x. They are not like terms. And then over here, I still have the 1/2. And now I'm going to get rid of the half, so I'm going to multiply by the reciprocal. And that becomes 2 over 2, which is 1. That's why they're gone. And I'm going to multiply this whole thing by 2. Okay? So real quick, that means I'm going to get 2x plus 8. So I'm moving over here on the left side of the wall. And on this side, I still have the y plus 8. Oh, sorry, 3 cubed. And now to get y by itself, I'm going to get rid of the exponent. So I'm going to cube root it. So it means on this side I just have the cube root of 2x plus 8. And on this side I have y plus 3. And now it'll get y by itself. I'm just going to subtract 3 to the other side, which this is in the cubed root, and that minus 3 is going to be outside of the cubed root. And that's your function. And then you can replace y with the inverse notation. So here is my inverse right here. That was a tougher problem. All right, next one. Find the inverse. So I'm going to make this y. Then I'm going to switch x and y around. And now I'm going to get y by itself. So working backwards in the order of operations, there's no addition subtraction except inside the radical, but I can't get to that until the radical's gone. So I'm going to move the multiplying. Since they multiplied by 2, I'm going to divide by 2. So x over 2. You could also write it as 1/2 x if you want, doesn't matter. With the square root over here. And now to get rid of the exponent or the radical, to undo a square root, I'm going to square both sides. And that means I'm going to square all of this, or this, whichever you want to look at. So anyway, on the right side of the equal sign, we're just left with y minus 5. On the right side, I'm going to square the x for x squared, and I'm going to square the 2 for a 4. Or I'm going to square this x and 1/2, and 1/2 times 1/2 is 1/4. There's the 1/4. And now to get x by, or y by itself, I'm just going to add 5. So the way I'm going to write it is 1/4 x squared plus 5. And then again, you can replace y with the inverse notation. And there's your inverse. All right, last part. Oh, not last part, but for the new stuff. We're going to use composite functions, and we're going to see if these really are inverses of each other. So the idea is, if I take g and put it into f, or if I take f and put it into g, when I'm done simplifying it, I should get x in both of them. So first I'm going to take g, and I'm going to put it right in there. So the x is going to go away, the 2 will still be there, but in its place will be 1/2 the square root of x minus 1. And normally x was squared, now this is squared plus 1. And I'm going to go through and I'm going to keep track in this little box in the middle of what I do first. So the first thing I'm going to do to clean this up is just square both things in here. So I'm going to square the 1/2, so that means 1/2 times 1/2, which is a 4th. And I'm going to square the square root, which gets rid of the square root, and I have x minus 1. Okay? Now I still have a 2 that applies to everything in here, so I'm just going to put that right here. So the first thing I dealt was the exponent. And now, so I guess those, the 2's, I don't know how you would say it. And now I'm going to multiply 2 times a 4th, and I'm going to get a 1/2. And then it's a 1/2 with x minus 1 plus 1. And now I'll multiply this in and get a 1/2 minus a 1/2, sorry, 1/2x minus a 1/2. So I'm not going to be getting to just x, because in the end, when I add the 1/2 and the 1, I'm going to get a 1/2x, and then that is just a 1/2, and I don't have just x. So there's no way that these are inverses of each other. So this answer is no. If it doesn't work for one, don't bother trying for the other. Okay? Okay. So let's try this one now and see if these are inverses of each other. Okay? So the idea is I'm going to take this, same idea, when I do the composite functions, I should get x. All right? So first, I'm going to do this one. G is going to go into f. So all of this is going to go right in there. Okay? So if you notice, I mean, these are kind of similar to each other. Those are the same, but these are different. So the 2 is going to stay there, and x is going to go out of the way. And in its place is going to go this square root of x minus 1 over 2, and now all of that's going to be squared with 1. So the first thing is to clean this up is I'm going to square what's in here, and when I square, I'm just squaring the square root. So the square root is now gone, they've canceled each other out, and I have this. So I dealt with the, I guess, the exponents first, kind of with that box. And now I'm going to do some multiplying and dividing. I'm going to get rid of the 2's. So 2, look at this as a fraction. These 2's are just going to cancel out. So then I'm left with the x minus 1's. So I got rid of the 2's next. And then the 1's can cancel out, so I got rid of the 1's last. And when I'm done, I just have an x. Okay, and this order does matter, because when we do this here, we're going to actually do it backwards. So this time f is going to go into g. So all of this, sorry you can't see that, is going to go right in there. So here's my square root. In for x is going to go 2x squared plus 1. And then you still have the minus 1 over 2. And now we're going to work backwards with how we get rid of things. So at the end, I got rid of 1s. Here, I'm going to get rid of the 1s first. These will cancel out. And I just have 2x squared over 2. Then I'm going to get rid of the 2's. The 2's will cancel out. So now I have the square root of x squared. And now the exponents, radicals, will cancel out, and you'll just get x. So these are inverses of each other because I both got x. Here I never got to just x, so they're not inverses of each other. All right, this is the last problem. Okay, determine the domain of the following functions. So the idea is you should be able to look at these without graphing them and tell me the domain and the range. So first, a cube root looks like this with infinity symbols. And so as was discussed on the graph on the front, this is the domain and range of infinities, like we did here. Okay? That's not going to change even if I stretch it, make it go right 5 and up 1. They are going to stay the same domain and range. So x goes from negative infinity to infinity, and so do the y's. Okay? So in this one, the flip will just make it go like this. And while this stuff might change, you know, x is going to the left, it's getting smaller, but y is going up, it's getting bigger. And to the right, x is getting bigger, but now to the right, the y's are getting smaller. The lowest x is still negative infinity to infinity. And the range, the lowest y, is still negative infinity to infinity. So with cube roots, this is always your domain and range. Always the same, no matter what. No matter your stretch, your flip, your left, your right. Now, square roots are something different. Normally, this starts at 0, 0. The stretch isn't going to do anything to 0, 0. But the 4 is going to make it actually go left 4. So now it's starting at negative 4, 0. And then when I put the infinities here, so now when I do my x, it's going to start at negative 4 and go to infinity. But my y's will still be 0 to infinity. Okay? And this one, again, normally it starts here, but now it's going to flip, and it's going to be this dashed line instead. All right? But it's still 0, 0. And then it's going to be going right 3 and up 1. So the final shape is going to be this purple line, starting at over 3, up 1. And now when I do the arrow, x is going to the right, so it's infinity, but the y's are going down to negative infinity. So when I do my domain of the purple line, my first x, my lowest x is 3, my biggest x is infinity. So 3 to infinity. When I look at my y's between 1 and negative infinity, the lowest y is negative infinity, and the biggest y is 1. Okay, so always smallest then largest, and that is your review. Definitely some challenging problems, but hopefully we've had enough practice.